Now, just now we stopped at PRT, and we mentioned about PRT is a method that use probability. So let's look at what are the terms that we use inside PRT network. So first one is beta distribution. So beta distribution is you can see as a probability or statistics distribution. All right. For probability, it uses 3 time to estimate, to do projection, to do forecasting. Okay, so under PRT, you look at 3 main time frame. One is most likely time, I label as M. One is optimistic time A, pessimistic time B. And by looking at the yellow wording here, you should able to guess what is their meaning. We have three possibility of the time completion time, or 3 possibility when you talk about time. When you do a project, we talk about time. So there are 3 possibility in time management. One is that most likely means that if you go through any projects, most likely time means if 10 project, 9 project can complete in 3 months, means you can use the 3 months for most likely time, means the highest frequency that you can use to use in the calculation. Okay, the first one, M. All right, most likely time means the highest frequency that it will happen. Okay, or we call it a numbers or the time that you use for normal operation. Okay, then the another one is optimistic. A, optimistic means the best condition. B, pessimistic time means the worst condition. So we have 3 condition time we look at here. M, A, B, or most likely optimistic and pessimistics. Okay. So basically, I already explained these 3 just now. Okay. What is the calculation that involved in PRT? This will be the first equation for today. We'll find the mean time or expected time. The first one, we use A plus 4M plus B divided by 6. We take what is A again? A is optimistic, means everything happened according to plan. Nothing delay will happen. All good. Then there's an A there. B is worst case scenario. Wow, everything bad happen, bad luck. You use B time here. Then 4M means 4 highly possible happen time. You put it here. So you have A plus 4M plus B. You want to find a mean. So how many how many times you have on the sample here? You have 6 items here. 1, 4, 1. So total you have 6 times above. You divide by 6, you get mean. Okay, so for probability, for PRT analysis or network, this is the first equation that we use. So quite direct, just remember and apply. Second equation for today, or for second half, is called variance. This one you're familiar with the equation here. So B minus A divided by 6 square. Okay. So these 2 equations that we use under PRT. Right? Mean time or expected time, you use this equation. Variance is B minus A divided by 6 square. And You have a beta distribution over here. I think you're familiar with this histogram or statistical curve here. All right. So as on the screen here, maybe you can't see the axis here. The axis here is, later I have, okay, I don't have the enlarged version, but you can download the slide later. So what is this one? This one is your time, not time. This is your possible time. And this is your A and B, right? Your time. So, but anyway, by looking at the curve, this is the most normal one. We call it normal distribution that you learn in your statistics. Most of the time, most of the case you face in your Max 1 or Max 2 when it comes to probability question, you have this kind of graph. We call it bell curve histogram or bell curve graph. So what I mean by normal distribution? You can chop the graph into half. Each side have the same area. Okay, each side have the same area. The total probability. This graph we use to estimate things. So what is the highest probability you have from the graph is 1. If you have a probability 1, means you have 100% the thing will happen. Okay, so the area under the graph, this is the revision about the probability that you learn in mathematics. So when you look at a normal distribution here, area under the graph is the probability of that things will happen. Meaning the area under this curve, this side plus this side, total area under this graph is 1. And then you have a normal distribution. What I mean by normal distribution? You have a symmetrical behavior, one on the left, one on the right. Which means total area of the graph is 1. You break into half. So if it falls under this area is 0.5 maximum. This one also 0.5 maximum. And then there's a table to find the area under the graph. Later, you find the value over here. Later, there's an equation, you find the value. And then you project up, read the table of the area. That is the probability of that particular case will happen. Okay, so on the top here, you see the tip of the curve here is shifting. This one also shifting. Okay, so as you can see here, this curve, if you compare to the middle one, this curve is towards one value we call M. Again, what is M? M is most highly it will happen. So you see the curve is towards to the left, and then the T is here, the mean is here, most frequent is here, and then this one is shift to the right. You have a M here, T here. Okay, now what is important about these slides? This equation, and the curve shape. Anyway, for this module, we will use normal distribution rather than this one or this one. So pay attention to normal curve, or you just need to flip back what you learned in your probability chapter in mathematics. You apply the scenario using the curve here. Okay. So 2 standard equation for this second half. Okay. Next, we talk about normal distribution that I showed you just now. So normal distribution means if you take the area under the graph, okay, normal distribution means you have a symmetrical probability either on the left or on the right. So half of the graph will be 0.5, half of the graph will be 0.5. We talk about what I mean by 0.5. Again, area under the graph, if you get 1, it means 100% will happen. So half of the graph is 0.5, means if your graph is 50%, it will fall in the white color region here. Okay. Okay, so maximum case will happen is 0.5 in the, not maximum, maximum is 1. But if you talk about probability of that thing will happen, normally you need to find the line of this line here. Okay, later you need to find the line of this one and this one. It is the X here. Then you'll find the area under the graph. So area under the graph again is a probability. So maximum probability is 100%, which is from here to here. Or area under this curve is 100%. You chop into half because this is a normal graph. Normal distribution means it's a symmetry between two sides. If you, from the tip of the curve, you chop half 50%, half 50%. Okay. We will calculate the Z. Again, this one is just a revision for probability or statistic chapter. We use this equation. Z equal to X minus mu divided by variance. Okay, this is what you learned in the Max 2. Z equal to X minus mu divided by this one. Okay, so this is mean time. I'll just copy somewhere in your revision there, revision notes there. Z, what is Z? Z is actually this point. Later, you read Z value from the table that I will give you later. Okay, or you can find in the appendix later in Teams. All right. So Z is something that you find on the curve here. You plot here. Okay, this is your Z. Yeah? Z equal to X minus mu. Mu is a mean. Is a mean divided by variance. Okay. We need a table to do PRT analysis. The probability table. So table, you need a table called table appendix A.1 in appendix A. All right. So I believe you can find it in the Teams right now. All right. You should able to have. Or I'm not sure whether I put in the tutorial handouts for chapter 3. I think I have lah, but if I forget, just remind me to give you this table. Okay, so you need a table, probability table to do this question, yeah, to solve PRT question. So once you copy this equation, Z equal to X minus mean divided by variance. Okay, we'll look at one example. So you should have this chart by the time you're taking your test 2 or final exam. Okay, you should have this chart standby with you, or you will see this one inside your question paper. Usually at the last page of your question paper, you will see this chart, same chart. Okay, this chart you should be seen it before in your mathematics again, under statistic or probability chapter. Okay, so what does this table tell you? Actually, all the equation was given, right? All the given. Z is given, the equation there, although it's very small on your screen. But once you get the appendix or table, you will have the equation and the shape of the graph is there. So there's no reason you don't know how to solve question if I ask about probability. Okay, so the equation is there. Even the marking, it show you where to mark. So what does this table tell you? You will start from Z value that you calculate with the equation just now. First column here, the Z value you calculate using this equation. Z equal X minus mu divided by variance. Okay. Once you calculate your Z, go back to this table. You have Z value over here. And what does all this value means? What does 0 mean? What does 0.1 mean? 0 means a normal curve. 0 means this line is 0. You start from 0, meaning you have a normal curve And this will be the only column that will ask in test or final exam. So you know the scope, huh? So all the value after 0 is not relevant to you at this moment. But when you go to work, you need to see all this value, right? For this module in your test and final exam, only these two columns is important. Z and 0. Unless I change the focus of your curve area. But at this moment, I still very kind. I will use this column only. Okay. So if there any change in the question in the final exam, I will let you know. But at this moment, I will only focus on this column only. Z and the 0 column. The rest is irrelevant at the moment. Again, what is the value of 0 and all this value? Is the value of this line. Okay. Let's look at one example. Okay, make sure you have the tutorial handouts because it's a very lengthy exercise for PRT analysis. All right. Okay. You read through this tutorial question. So basically, you have a tensile company. They want to develop a new system for their processor, for their system, for their factory system, and they want to see whether the new system that you design will able to work better than their old system or not. Okay, so the one that you see here is a network of a new order processing system. This is a network done by you and your team that proposed to the top management. Okay, so this is the diagram that you should be familiar with, where this is the Aon network. You see from the start to finish with the bubble. Okay, with the bubble on the top and at the bottom. So on the top is the activity number. So you have 1, 4, for example, 1, 4, 10, 2, so on. Okay. But something a bit different from the previous diagram. There is a 3 number below the balloon. Okay, there are 3 number below the balloon. Okay, so it's a very lengthy tutorial question, yeah. So you have the diagram or the tutorial question. So it tells you some stories. It tells you some story. Basically, what is activity 1, activity 2, activity 3, activity 4, activity 5, activity 6. But basically, this is just a derivation or just an explanation of what is this network. You're already familiar with this network already. Now the tutorial question here, it just changed the activity and the sequence of the activities. The concept still same. All right, you still see bubble, you still see arrow, and there's a time there. In this example, the time is a little bit different. You have 3 numbers below the diagram there. Okay. The rest, this page is more explaining about the activities here, right? So basically, you have 10 activity, which is a very busy, I cannot say complex, but a very busy system, very busy network, compared to the 7 activity that we discussed previously in building a house, 7 steps. So here we have 10 different activities. No, we have 11, sorry. We have 11. If you look at this diagram, the final activity is 11. Okay, 10, 11. So total we have 11. So quite a lot of work here, quite a lot of calculation here. Because you try to imagine, you need to convert this one into another diagram. So I will cut short. I will cut short. So you'll see the similar pattern in your test or final exam. All right, you will see a network diagram. You explain some scenario to you, but basically you just test your concept whether you know how to do analysis with this diagram or not. Okay, so the second paragraph here is just to explain what is the process, what is the precedence, what is the relationship. By looking at diagram, in all this arrow, you already know which one should come first. So basically, without reading this one or not, you already can understand. If you can understand the diagram from the previous lecture, you should be good to solve the question already. Okay, so this page is about the activity. This is your homework. You can read about all this activity. Now, this is the main task of this tutorial question. So the 3 times estimates, it means that below the diagram that you have on your tutorial handout there, on this diagram, you see the 3 numbers there. Okay, the 3 numbers in the diagram, what does it represent? It represents mean, variance, and what else? Estimates, mean, variance. Okay, so you have 3 numbers here. It represents A, M, and B activity. Okay, we did define what is A, what is M, what is B. You build a table from the diagram. Once you see this diagram with the 3 number below, the next step is to build this table. So the format of table standard already. Activity, the first column. Second one is the time. You have 3 times to do PERT analysis. 3 times, likely, optimistics and pessimistics. You have A, B, and A, M, and B. So given in the diagram, you have 3 numbers there. So for example, why the first activity is 6, 8, and 10, where you get 6, 8, and 10. Go back to the diagram. I'm not sure whether you're able to see. On the screen here, you see activity 1, 6, 8, and 10. We copy the number, put into the table. 6, 8, and 10. Do the same for activity 1 until 11. It's going to take a lot of time. Build this one. In the exam, this one will cost you 15 minutes just to build this one. Okay? In the exam, minimum you have 10 activity, just to give you some idea what is going to happen in your final exam or coming task. Minimum you're going to have 10 activities, but with the help of this table, you should able to calculate very smoothly, right? So activity 1, you copy the A and B from the diagram. 6, 8, and 10. Once you copy this one, you start calculation on the right hand side. Okay, before we move to this one, any question on building this table? Any one of you don't know what is A, M, B, you don't know how to get 6, 8, and 10. You don't know how to get 1, 10, 13. Any one of you don't know? Ask me now. Sarini, okay? Sarini, are you there? Calling Sarini. Is your mic working? Let me check your attendance. Sarini, are you there? Calling Sarini. First time. Calling Sarini, second time. I'll give you chance, Sarini. Please respond if you hear my voice. I'm sending another chance for you. I'm sending WhatsApp text. If you do not respond, you consider absent. So I give you 1 minute time to respond. If you do not respond, you consider absent from my class. Okay. Next person I'm going to ask, Guru Darshan, are you there?
Yes, sir.
Okay, good. All right, now Guru Darshan, do you understand how to get the numbers of A, M, and B?
Yes, sir. From the
Okay,
diagram.
yep, correct. Okay, good. All right, now we move on to the next column here, which is T and variance. So you build this table, basically you copy the format activity A, M, B, then you find the mean time T. So we already covered the equation for T. Where is T? T is this one. Variance is this one. However, this one is variance square. Okay, variance square. So when you calculate this equation, please have a square root. Yeah. Please put this one to the right hand side. So, okay, so this one, for this table, you still need the square. But when you calculate the z later on, you need to find the square root number. Yeah. So for this table, okay, for this table, I put the hints here. There will be one question on this one already. Yeah. So make sure you know it's a standard one. You see this diagram, you convert into table, activity A, M, B, mean times and variance. You calculate. So this one you have 11 sets of activities, 11 sets of data. So you key in the numbers here. 6, 4, 6 times 4, 8. Right? 6, this one, plus 4m plus b divided by 6, you get 8. This one is b minus a divided by 6 square. You get this one. You calculate for the rest. This is your homework, yeah? This is your homework. Go and verify this number in my slides. Okay, Sarini, are you still there? I saw your message saying that your network is not good. All right. All right. Yeah, but at least you respond, yeah? Okay, good, Sarini. Right. So you need, yes, go ahead.
Actually, yes, sir. Actually, for me and my friend here also keep reconnecting again and again. I
Okay.
don't know, maybe today because of the flood, maybe
Yeah.
some internet
Okay.
connection.
Right. Okay. Yep. Okay. So yeah. So yep. Okay. Thanks for the response. Yeah. Thanks for the response, Sarini, for telling me, and also the one that just responded just now. Okay. All right. So these are the things that we calculate. So this is just a side note for this one. All right. So this side note, I did explain how to find T and variance. Okay. Even I show you one little step here. You get Edwig's. So how to find variance? Okay. Find variance. You square it. All right. B. What is B? B is 10. What is A? Is here. Divided by 6. So 10 minus 6 divided by 6. So here you get 4 and not 4. Is it correct? 4, 6, yeah. 4, 6, you simplify, become 2 and 3. Right? 4, 6, you simplify, become 2 and 3. You multiply 2, not multiply 2, but you square it, you get 4 over 9. Use your calculator, put in the decimal place 0.44. Okay, 0.44. All right. Yeah, Sarini, I get your message already. Thanks for your response. Yeah. So those who are missing and your line is not good, you can watch back the video. You just watch back the video that we recorded. Yeah. All right. Okay, so this is how you get 0.44. So I think the step you already demonstrate to you. So I think it's very clear for everyone. The rest is the same process, right? It's the same process. So if you are good with Excel, if you're good in Excel and you know how to do simple programming, this actually is a very fast calculation for you. Yeah. All right. I'm not sure the exam.net have these tools or not. I'm not sure, right? Okay. All right. So the next one, after you build the table that I show on this one, after you build this table, right? After you build this table, the next step is that you try to find the critical path. Okay, try to find the critical path. So how do you find the critical path? You find those with a zero slack. How do you build a zero slacks? Okay, so the next step will be very, very time consuming because it's going to use your M. You use your M value as the
Hello,
time.
sir.
Yeah, I can hear you. Yeah. Okay, Sarini, you
Okay,
are
sir.
back.
I just joined because my internet connection wasn't good just
Yeah,
now.
yeah, yeah. Yeah, I saw your message. Yeah. Thanks for your message. All right.
Okay, sir. Thank
Yeah,
you.
in fact, it happened to your other friends also. So yeah. So okay. So anyway, Sarini, if you missed the maybe 10 minutes lecture ago, you can rewatch the video. All right. Now, once you build this table, you focus on transferring the information from the table into the diagram that we have covered last lecture. Okay, how you build this table? You focus on one column of information, which is the time for the M column here. For example, activity 1, M value of very, very small. So for example, activity 1, the M value is 8. So how do you build the matrix for activity 1? So this is activity 1. Activity 1 time is 8. Okay, activity 1 time is 8. So you copy the M value for other activity. Important, after you draw this diagram, you check whether you have all the activity or not. Don't miss one. If the table have 11, or if the diagram given have 11 activities, make sure in your table or in this network here also have 11. Yeah. So I'm not going to explain how you get this one already, because we already explained, and most of you participate in the calculation of this kind of metrics before. You do the same. Okay, you do the same by using the time of M for the activity, and by using this, meaning you use this table, the M column, and this diagram, meaning you change this balloon here, the time here, you ignore the other two, you only focus on M. Maybe you need to redraw the whole diagram of this one and only write activity and the time by using the M value there. Okay, so after you build that one, you combine with the table, or you can straight away use the diagram, this one, this diagram, after you modify, after you remove the two side number, or maybe you can just use your pen to circle the middle number there. You use this diagram, do the same as the previous explanation that we have done. Convert this table or the diagram that you see just now into matrix diagram or this 6-grid diagram. Okay. Now I want you to focus on this diagram. Okay, since Sarini, you are here. Sarini, you're here, right? The network okay now? Sarini, are you still there, or your network still not stable? Okay, if not, then it seems that Sarini line is not stable. Let me ask. Nevin, are you there, Nevin? Nevin, are you there? Nevin
Yes,
Sham.
sir.
Okay, Nevin Sham. You still remember there's one question I asked Sarini this first session. I asked her to observe the critical path or critical activity, critical path activity, right? You still remember I asked that
Yes, sir.
question? Yeah.
Yes,
So
sir.
by looking at this diagram, I'm not sure whether you can see the numbers. You can see the numbers, right?
Yeah, I can, sir.
Okay. Now, can you identify which is the critical path? Can you identify the critical path or critical activity from this diagram? And explain how why you say they are critical activity.
Just a second, sir.
The rest you can help to observe also. So the question for the class is that the question for Nevin is that can you identify the critical activity from this diagram? It's the same question I asked Sarini earlier. All right. The rest you can observe and try to cross-check whether Nevin is giving the correct answer or not. Nevin, you understand what is critical?
Sir.
Yeah.
2, 5, 8, and 11, sir.
2, 5,
8, and 11.
11. Why? What is the reason?
Because that's the longest part, sir.
Beside longest part, what is the observation for critical path activity? You still remember what Salini said? Or what I asked Salini? Yes, one way is true calculation, correct? I mean your method is correct. Do you still remember I mentioned something that this one must be same with this one? This one must be same with this one?
Yeah.
Yeah, so it matched with your analysis just now. From this table, you observe when below same as above, it become critical activity. Same with this one. You mentioned just now.
So is it because the earliest start time equals to the latest start time?
Correct. It is because here. Sorry, I'm still not very used to my green screen. So this one equal to this one means latest start time will equal to your earliest start time. So it cannot afford any delay, even the finish time also. Okay, the latest finish and the earliest finish also same, because if the number is same means you cannot afford any delay. So that's why you see from the activity that you mentioned just now, 2, 5, 8, 11, they are critical path. Okay, the rest, are you able to see? Are you able to understand what Nevin said just now? Are you able to find the critical path by looking at the diagram? Just by comparing the numbers. Okay? Or if you're hardworking, you can calculate. All right? And calculate the maximum time. Or you can go and do mapping one by one. But the fastest method, since we already learned the method in the first session, apply it. You go and see whether got same number or not. Then you look at the arrow. Does it connected or not? Okay, then that is
yes, doctor, I have a question.
Yes.
The one we are taking is the mean time, right? It's not M, right? below the activity.
You mean this one, the numbers
Yeah.
here?
Yeah.
Number here, we take the M value from the table. The M value. Okay.
Okay, Doctor.
Okay. So just take note. The numbers that you use to build this diagram is the M number, is the mean number, or not mean number, but is the most sorry, let me see.
Doctor.
Check. Let me see. Number 11 is 9. Oh, sorry. It should be used min. It should be used min. Sorry.
Okay.
If I look at here, something wrong with my slides here. It should be using min because it's 9. 9 for 11. Yeah, 9 for 11. 10, you use 4. And use 4. Are there else? Let me check. 6. Yeah, the rest is same. Activity
The activity
number.
5 also.
Activity 5. Activity 5 is 3, which is same.
Sorry, activity 4, Doctor.
Activity 4 is 5. Activity 4 is 5. So yeah, we should use min rather than use M.
Good.
Okay, let me correct my slides. Let me correct. Apologize for the wrong information. Let me do correction right away. Okay, let me move my arrow. Oops. Should be mean time. Okay. Sorry. Yeah. I think it's my arrow mixed up with my slides here. All right. We should use mean time. Sorry. Because here I write mean time by my arrow pointing to M. Sorry. Okay. Correction. For the numbers, for the time below the matrix here, we use the mean time in your table. Okay. Mean time. How to find mean time? Is this equation again. Okay, this is the mean time equation that we use to find the time. Again, now to build the matrix, we use mean time. We use mean time, this one, to build the network here. Okay, correction. So the time here, this corner, is not use M. It's not use M, correction. It's use T over here, mean time. Yeah. So align with the statement here. Okay. Right. So again, how to build this one? Go to watch the previous video when we go through how to get all these numbers. You have forward pass and backward pass. We have forward pass and backward pass. Forward pass, you take the maximum time. Backward time, you use the minimum time. Okay. All right. So this one already identified the critical path. Next, we be back to the table.
Doctor, one more question. Sorry.
Yeah, go ahead. Go ahead.
Yeah, like this one, that the network, if we want to complete, then we need the Gantt chart also, right?
Sometimes I just skip the Gantt chart and maybe I'll just give you this table.
Okay. Doctor.
Yeah. So it depends on because when we design the question, we design a question. We need to consider the time that you need to solve. If the question take you too long to solve, then the exam time will drag further. So it's still, we need to go back to the learning outcome that we try to ask you, right? So for example, we want to test your concept, whether you know how to apply or not. So sometimes I will just skip some steps and straight away give you midway information and see whether you can connect from there to the results that we expected. So that is how we ask set question. Okay, so maybe for test 2 you will still see Gantt chart, but maybe final exam I will just jump the Gantt chart and you will see this instead of the Gantt chart. You see something like this, or if the question is too long, then maybe I will just give you one sample of this diagram, and even I give you this table also, without the mean time and the variance. I will just give you this format and you find the t and the variance. Equation won't be given, but you will be guided to solve question. Either you use this table or use this diagram to solve this kind of question. So build this table. Again, you can see the importance of this matrix table, this network. So if you're weak in this one, go and practice. Go and practice and remember the strategy, the steps involved. Yeah, how to get the numbers in these 6 metrics here. All right, the same. Okay. All right. The next one is that you need you can extend the table from the available table just now. You can extend another 4 rows, 4 column, 1, 2, 3, 4, and then find the slack time. So you have the t, you have the variance just now. Just extend another 4 rows, or 5 column. ES, EF, LS, and LF. The purpose of having these 4 columns is to calculate your slack time. How to find slack times? You focus on 2 columns only. ES minus EF or LS minus LF. This one minus this one. Sorry. Yeah. Is it correct? Oh, sorry. LS minus ES, not EF. This one minus this one. This one minus this one. Okay. So I will recommend you put the column together, the one that you can calculate. But you can follow this format also. Right? The important point is we want to calculate slacks. Okay. Want to calculate slacks. Calculate this S value, slack time. So LS minus ES, you get 1. Or LF minus EF, you get 1 also. For example, how to get 0? LS minus ES get 0. LF minus EF also get 0. You do the same for the rest data here. From the slack time, you can identify which one is the critical activity, right? From here, also from the diagram, same. So either from diagram, you can highlight with a circle, which is the critical activity with the same value of the matrix here. Or from the table, from slack times, those with 0, it means it's a critical path. 2, this one you read, 5, 8, and 11, something like that. Okay, so this one, the purpose of this table, after you build this one, you expect to see question ask you about slack time, calculate slack time. So this is the table that we expect from you. This one will cost you about another 10 minutes just to press calculator to calculate this one. Okay, any question on this table? Everyone good? Sarni, are you on the line? Or still not getting good network?
Yes, sir. Yes, sir. But the line is a bit like breaking.
Okay, all right. All right. So do you understand the purpose we built this table, Sarini?
Yes, sir. A bit.
Yeah. Okay. So a bit. So there's only one purpose we have this table, is to find the slack time. Why we find the slack time? is because we can identify the critical activity or critical path activity. Okay. All right. Thanks, Sarini.
Okay, sir.
Yeah, I know you're struggling with your line there, but yeah.
Yes.
Yeah. So thanks
Okay, sir.
thanks for your effort trying to follow along. Okay. Yeah. Again, I highlight all these with 0, 1. You will identify the critical activity either from the diagram or from the slack table here. The next one is all the flexible times that you can play along here. Okay. So I put a table along. So from here, it just to emphasize again, either from this network diagram or from the slack table here, you can identify the critical path activity, which is 2, 5, 8, and 11. Then how to find variance of the whole projects, how to find the variance for the whole project from activity 1 until activity 11, which is the last activity, activity 1 until 11. So to compute the total project variance, you only need to focus on critical activity. It is give you this simple equation. You take variance 2, variance 5, variance 8, and 11. Why we take them? Because one, they take the longest time to finish, and also they can't afford to have any delay in the process. So as long as we deal with this critical activity, which is in this case, you have 2, 5, 8, and 11. Do the activity. 2, where you find in the table, you already calculated, right? So 2 here is 1. 5 is 0.11. 8 is 0.75 here. 11 is 4. You add them together. So your variance for the whole activity is 6.89 weeks. Meaning, what does this number tell you? It means that you need to monitor your projects as a project manager. If your delay from activity 1 to 11, if it's fall outside this, maybe 6 weeks or 7 weeks, you are in big trouble. Meaning your project's going to delay time. If your activities your times, you see the mean time here, 8, 6, 3, 9, and so on. Meaning if you monitor, you're so busy and you come up with this calculation, variance, this variance number. What does this variance number tell you? You as a project manager, you know roughly an idea what you need to trigger backup plan if your activity more than this number. Okay, so it's good. Your work can be completed below 6 weeks, but if your activity finish more than 7 weeks, you have to start worry because something will be go wrong in your forecast in your planning already. Okay, or this one you can say more or less your activity, if your activity can be finished within 6.89 weeks, all right, you still can catch up the delay time within the process. Okay, so this is what it means, all the numbers, what it means. Let's look at the time here. Okay, do you guys can still go or you want to continue Wednesday? You have tasks this week? Yeah.
No, Doctor.
Okay. All right. I think seems that we have a connection problem and some of our members here. I think we stop here. We'll look at example 2 on how to use the histogram or the normal graph to estimate the to estimate the time. Huh? Or you guys can still all go on? Yes, no? Okay, I think we stop here. Huh? I think we stop here. Next lecture, we continue with example 2. All right, let me stop the recording.